This is your host Sapil Bhartia, and welcome to TFR Let's Talk. And today we have with us Barak Shoster, Senior Director and Chief Architect at Palo Alto Networks. Barak, it's great to have you on the show.
Thank you for having me.
Today's topic is something which is closer to my own, interest and our audience, which is supply chain security. But this is also a thing which I may be wrong, also needs a lot of awareness and education as well. So if I ask you, how would you define software supply chain?
So, software supply chain composites all of the different pieces that, as a business that builds application, compose the application that we build. So, it can be third-party software like open source packages that we're using, containers that we're bringing from the internet, the code that we're writing by our own, either by contractors or our own employees and engineering teams, and also the delivery pipelines themselves. So when we deliver new applications to our customers, we should ask ourselves, is the delivery pipeline secure? And do we maintain a full software bill of material called an SBOM on our entire software and its supply chain, including third-party vendors?
Why should companies care about software supply chain? What is the importance?
So let's take this piece of software supply chain into another supply chain, cars. Like Henry Ford built a car, built a supply chain, said we need a wheel, we need an engine, we need electricity, and third-party vendors built the engine or the wheels or other parts of the car. And on software, we started to do the same. We're using third-party pieces, open source packages, containers to build our own applications. Now, let's say that you buy a new car and you realize that one of its parts coming from a third-party vendor is not what you really expected. You got a flat tire instead of one with, with air in it. It's not safe to drive in that car from that moment forward. Or let's say that your engine got broke because it lost its warranty. So it's similar on a software supply chain. You're using an open source package that is not maintained by a legitimate source, not maintained by a legitimate vendor, um, and you need the tools to examine your software and realize that very early on. So software supply chain is a problem that today is not only the problem of security practitioners, but also the problem of the engineering teams. And as part of the shift left movement, a lot of those problems can now be solved very early on. So in Bridge Crew, we started with scanning infrastructure code, which has its own supply chain risks, and over time expanded to the delivery pipeline itself and the application software, including open source packages and their vulnerabilities.
Let's just talk about that this is a problem which is in general for any software that is written out there. It has nothing to do with just open source as well.
Correct. You can use a third-party vendor. For example, there was an attack on a vendor that we all used to use called SolarWinds, a very popular APM, a monitoring software. This attack was detected by the FireEye security team, and they've identified that the software of SolarWinds was malformed and leaked data that it's on their customers. So SolarWinds is a proprietary software. A lot of engineering teams can use it, and it was fixed since then. It's important to say, but in a specific version, you might have data leakage if you use the bad version of SolarWinds. So it can happen on APM software that you're using. It can also happen on CI software that you're using. CodeCov is another attack that happened last year. CodeCov is a code quality scanning software, which made sure that your test coverage over your application is whatever you have expected to be, high, let's say. But it also caused some leakage of secrets from your CI/CD pipeline, which is one of the new crown jewels of application delivery. So Even paid software or open source software can have vulnerabilities, and it's because everybody can make mistakes. It's not always easy to follow the security best practices. And one of the things that we try to do is to reduce that friction and to make it simple to every engineer out there to secure their development lifecycle.
We are hearing a lot about supply chain security. What led to this surge in discussion about this topic? Because if you look in cloud native world, security is different from traditional IT. We have started hearing a lot about security in the cloud native world, but why so much about software supply chain and SBOMs now?
So one motivation for that is the recent attacks that are very sophisticated that we've seen in the past 2 years over the entire supply chain, from open source packages to the configuration of version control system itself to the CI workflow system itself. But also, a lot of organization went through this digital transformation, breaking monoliths into microservices, changing and modernizing their cloud infrastructure. And it introduces a new set of risks and also a new set of opportunities. On the cloud, everything is API driven. When we declare everything on infrastructure as code, it's now declarative and version controlled. And for the first time, we have the ability to scan, understand, and fix it early on. We didn't have that capability when everything was a monolith, did not have an API, everything was proprietary. It was really hard to secure it, and it was really hard to make it streamlined as part of your agile sprint as an engineering team. It was very waterfall oriented, and you had the ability to release software only once a year or twice a year. But now, when you're releasing software multiple times a year, you really need a solution that will scan every change of your code base, of your software bill of materials. And the only way to jump on this new cadence and this new velocity is to have a new solution that will scan continuously your software.
How developers can help improve the security posture of their company?
For the first time since we brought everything into code and everything now is declarative, the open source packages that we're using are declarative in the package managers. The infrastructure as code is declarative, and the containers are persistent in a declarative way, both in Git and on the different registries. It introduces the ability to put scanners in your CI pipeline and linters that will tell you, hey, you have a mistake over here while you're writing the code. So either on your IDE, your VS Code and JetBrains, so you'll have the ability while you code, before even you're committing the code, to see where you have issues and how to fix them. And the second phase would be to put those tools, those scanning tools in your CI pipeline, and to fail a build, stop it and fix it before it arrives into a real environment, into a production environment. And also have a pull request process where different teams can collaborate and review, and also automatically use some of those tools to automatically review and fix your code base. It brings in a cultural change. Before that, security teams were siloed, and they were the smart guys that knew how to secure your application. But once you're putting the security tooling into the CI/CD pipeline, you're democratizing this knowledge. Now, any engineer can understand, hey, I have issue in these code lines, and this is how to fix it, and now I have the context, and I'm educated not to do the same mistake again. I'm more productive, and I'm fixing it before it's arriving to a real environment. So less Jira tickets, less unpredicted work, less burnout. So it's a really positive revolution on the engineering team to get this kind of responsibility. And it happened in the past already. Like 15 years ago, we had the democratization of unit testing, of the QA profession into the different engineering team. And now engineering teams are writing automated tests. And on the past 2 years, that's the revolution that is happening for security teams. Engineering teams are starting to write the security tests to automatically scan them in a continuous fashion.
Since you talk about automation, I also I'm kind of curious about this topic because once again, that is a topic I cover closely, which is the role of AI ML in security.
In the context of operations, you can use AI and ML to understand, hey, I have a repetitive issue over here that occurs in my dev environment. Is it real? Is it noise? And it really helps you to understand what's the real issue in your haystack of alerts that can arrive to dev or production. That's one way to use that. And another way to use that is you can use AI to understand where a bad code can be fixed by a good code. So one example for that is Copilot that GitHub have launched, who can actually help you write better code. And also in Bridge Crew, we have a feature called Smart Fixes that does something very similar to the space of DevOps code, of infrastructure as code. So let's say that you're writing a new Terraform script or CloudFormation or Kubernetes script. While you write this YAML, Bridge will identify, hey, here you have a mistake, but in the past, other team members in your organization have written good code. Let's see if you can use those as recommendations to fix your code by the best practices that are used in your enterprise. So that's another interesting way where AI can actually be a recommender system that will fix your code while you're writing it.
How can this CI/CD based workflow can help developers in better coordinating with other teams, because security is not a problem of one team, it's a problem of everybody's team.
So different teams have different KPIs in the engineering organization. The full stack team is responsible for delivering the business logic as fast as possible to the new release of your application. But we see full stack teams are touching in the code base the Docker files, and they're using Docker images for local development, for testing, and the way that Bridgeview can help the full stack engineering teams is to scan those Docker files and tell you, hey, you have an issue there. You're using the wrong open source package. You should bump it to the secure version of it. Or you even have a misconfiguration in the Docker file itself, like you've exposed a port or you enable the root user as the default user of your Docker image. And for the SRE teams, those are the teams that are creating your cloud platform infrastructure, also named as platform engineering in some of the enterprises. And the platform engineering team can use the tools that Bridgeview provides to scan their infrastructure, their Kubernetes clusters, their Terraform code, their CloudFormation code in every steps of the delivery pipeline. While coding, before applying to production on the plan phase or in the admission control phase, and to have those last guardrails before applying a very misconfigured deployment. And in runtime, the ability to continuously scan your cloud environment and to verify if there are any drifts from the blueprint that you've defined in your code. So we see SREs and full stack developers really using our tools to be more productive and to reduce the burnout and the amount of unexpected Jira tickets in their backlog coming from the traditional security practices.
Now let's talk about the new threat modeling visualization. How does this help teams in, once again, improving their security posture?
So let's say that you want to deliver a new web application and it's a basic three-tier app. You have a database, you have your compute servers, and you have your CDN. You can have mistakes all over it. You can have your database public, you can have your compute with exposed port or unencrypted, using unencrypted volume, or an outdated container. And what we've done is we've released a new feature called supply chain graph that enables you to see a full threat model of your entire application. Understand where in the code there was a change, for example, in your infrastructure, that declared a container that is using a vulnerable open source package that is deployed into this cloud server. And this full threat model enables you to prioritize, hey, is that really critical? and what's the butterfly effect, what's the entire threat model or attack chain that is possible as a result of this change. And this is where this new feature called supply chain graph is coming to help you as an engineer understand the impact of the code changes that you're doing on every step of the way.
But I'm always curious about the direct impact on developers' lives, how it makes their lives easier. So if you can just, quickly give us, hey, this is how it changes their lives.
Nobody likes to get a pager duty on a Friday night. That's your day off. That's your time off. You want to be with your friends, with your kids, with your families. And when you get this call of a production issue, it's really pissing you off. So the best way to undo it is to write good code on the first place. So shifting left of those issues handling to the phase that you're coding will prevent from those issues happening in production. And as a result, will prevent this pager duty alert on your Friday evening. So that's how we improve the quality of life of engineering teams. And also, we make all of those applications more secure. So from business perspective, your business is more secure, your application that you're writing is more secure, and your work-life balance is better.
Barak, thank you so much for taking time out today and talk about not only this topic, but also how Bridge Crew team at Palo Alto are helping developers improve their life and so that they can have fun on weekends and not have to worry about pagers. Thank you for those insights, and I'd love to have you back on the show. Thank you.
Thank you, Swap. Have a good one.